Let's continue with the equations of tangent and normal lines. Look at the guided practice 4. Determine where, if anywhere, the tangent line to this function is perpendicular to the line y equals -1 over 2x minus 1. Perpendicular to the line, that means the slope of a tangent line equals -1 over the slope for this linear function. That is -1 over 2. So you get the 2. Or you can do opposite and reciprocal. From -1 over 2, opposite reciprocal, you will get the 2. After we get the slope of a tangent line that equals 2, we will do the derivative of f of x equals 3x squared minus 2x plus 1. Just using the power rule to do this derivative. This will be the slope of a tangent line. Equals 2. Then we solve this quadratic equation. As we know, this is a quadratic equation. The keywords you have to set up equal 0. So we get the 3x squared minus 2x. Here's minus 2, so minus 1. Do the ninja x, -3, -2 over 3 over 3. So we get the -3, 1. Then remember reduce. -1, 1. So x, you will get the x minus 1, 3x plus 1 equal to 0. x1 equals 1, x2 equals -1 over 3. When you check back the problem, they said determine where. So we need the coordinate for the points. F of 1 equals 1/3 power minus 1 squared plus 1 minus 2 equals -1. For f of -1 over 3, we do -1 over 3 third power minus -1 over 3 squared plus -1 over 3, then minus 2. You will get the -67 over 27, which means 1 -1 or -1/3 -67 over 27 will be the points we are looking for. Let's go to guided practice 5. The tangent to y equals x squared e to the x power at x equals 1 cuts the x and y axis at A and B respectively. Find the coordinates of A and B. When we talk about the tangent line, you have to do the derivative of a function. So remember, you have to use a product rule. That means x squared, we do derivative e to the x power plus x squared times e to the x power, we do derivative. You will get the 2x e to the x power plus x squared times e to the x power. We plug in 1 to this derivative function so that we can get the slope of a tangent line. That is 2 times 1 e to the 1's power plus 1 squared e to the 1's power. Altogether, you will get the 3e. You got the slope, and we need x1, y1. So f of 1 you will get the 1 squared e to the first power equals e. That means 1e will be the x1, y1. So that we can write down the equation of a tangent line. That is y minus e equals 3e x minus 1. When we talk about the tangent line cuts the x and y axis at A and B, you know that A will be x-intercept and B will be y-intercept. Therefore, we need to figure out the x-intercept and the y-intercept for this linear function. For A, x-intercept, that means I have to set up y equal to 0 to solve for x. So you get that 0 minus e equals 3e x minus 1. Negative e equals, we do distributive property, 3ex minus 3e. So move negative 3e to the left side, that's plus 3e. You will get the 2e equals 3ex. Then you divide it by 3e both sides. You will get the x equals 2 over 3. Which means for this A, you will get the 2 over 3 and a 0. Then for B, you just need to plug in x equal to 0. So you get the y minus e equals 3e 0 minus 1. That is negative 3e. Y minus e. Then you add e both sides. You will get the y equals negative 2e. So for B, the coordinate will be 0, negative 2e. Let's go to guided practice 6. Find where the tangent to the curve y equals negative x to the power plus 2x squared plus 1 at the point where x equals negative 1 meet the curve again. This question I will do a calculator video later on. The answer will be 4, negative 31. Let's go to guided practice 7. Find the equation of a tangent to y equals e to the x power at the point where x equals a. Hence, find the equation of the tangent to y equals e to the x power which passes through the origin. First of all, we need to figure out the equation of a tangent where x equals a. If x equals a, that means your x1 basically is a. So the y1 you will plug in here. That will be e to the x power. For the slope, you will get the y prime equals e to the x power. We do derivative still e to the x power. Then for the slope of tangent line at x equals a, we will get e to the x power. So we can write down the equation of tangent line y minus e to the x power equals e to the x power x minus a. We need the equation of a tangent to y equals e to the x power which passes through the origin. In other words, 0, 0 is on this tangent line. Now we plug in 0 minus e to the x power equals e to the x power and 0 minus a. Let's organize negative e to the x power equals negative a times e to the eighth power. We divided by e to the eighth power both sides. You will get that -1 equals -a. Therefore, a equals 1. After we get the a equals 1, we go back to this equation of a tangent line. You will get the y minus e equals e x minus 1. This will be the equation of a tangent line to y equals e to the x power, which passes through the origin. Let's go to guided practice 8. Find the equation of the tangent to y equals x squared minus x plus 9 at the point where x equals a. Hence, find the equation of two tangents from 0, 0 to the curve. State the coordinates of the points of contact. So we need to get the equation of a tangent line first. Then we will get equation of two tangents from 0, 0 to the curve. Third is we will get the coordinates of the points of contact. If we are given x equals a, that will be your x1, that's a. You will get the y1, plug in this formula. That is a squared minus a plus 9. Then the slope of a tangent line, we do derivative to this function. You will get the 2x minus 1. So the slope of a tangent line at x equals a, you will get the 2a minus 1. Then we use y minus y1 equals slope x minus x1. You will get the y minus a squared minus a plus 9 equals 2a minus 1 times x minus a. So this is the general form for any tangent line when x equals a. Now let's go to second question. We need an equation of two tangents from 0, 0 to the curve, which means 0, 0 is on this equation of a tangent line. So we plug in. You will get the 0 minus a squared minus a plus 9 equals 2a minus 1 times 0 minus a. Now we need to organize. We do the distributive property. Negative a squared plus a minus 9 equals. This is negative a, so distributive property. Negative 2a squared plus a. We know this is a quadratic pattern equation, so you need to set the equation equal to 0. So move everything to the left side. You will get the 2a squared minus a squared plus a minus 9. Combine like terms, that's a squared minus 9 equal to 0. So a squared equals 9, a equals plus or minus 3. After you get the a equals plus or minus 3, you need to plug into this equation of a tangent line. You will get the y minus. Let's plug in positive 3 first. So you get the 3 squared minus 3 plus 9 equals 2 times 3 minus 1, then x minus 3. We organize, you will get the y minus, that's 15 equals This will be the 5 times x minus 3. You can leave as it is like this. This is when x equals to 3. When x equals to negative 3, we can get y minus negative 3 squared minus negative 3 plus 9 equals 2 times negative 3 minus 1, then x plus 3. Then you organize, you will get the y minus 21 equals negative 7 x plus 3. This will be the second equation of a tangent line passing through 0, 0. We also need to figure out the coordinates of the points of contact. From these two tangent line equation, we can figure out the contact. For this one, this is a y1. This will be the x1, so 3, 15. For this, you will get the negative 3 and 21.